This video is on how to solve a greatest integer function equation, or how to solve a greatest integer equation. This is the same thing as when you have a greatest integer function and you are plugging in a y value and solving for an x value. So you could look at it as in an equation that has a greatest integer component, or you could think of this as where is the function y equals 3 times negative 0.5 x plus 2 in the greatest integer minus 1 equal to 17. And solving for the x value has a couple of ways to do it, but the way that we did it in class is like this. The first thing to do is to write this in standard form if it isn't already. And the reason we do that is because it's important to take the b value and just draw out one step. So that means drawing it out open in the correct direction and also of the correct length. Remember that the step length is 1 over the absolute value of the b. So this is one step. We're going to come back to that shortly. But the next thing we do is to isolate the greatest integer brackets, meaning move stuff to the other side, divide if we have to. So here I'll move this negative 1, divide both sides by 3. And at this point, once you have the brackets isolated, you have to verify to see if this number is an integer. Why do we do that? Well, these brackets mean round down to an integer. So if we got to a point where we rounded down, that would have to be equal to an integer. And if it wasn't, it means that it's not possible. If we said round down everything inside the brackets to an integer and make that equal to 1.3, there would not be any possible way to do that. But if this is equal to an integer, then we keep going as if these brackets weren't here anymore. So we drop the brackets and we keep solving. We divide by negative 0.5 and then bring this negative 4 to the other side. So I have found an x value. And the x value that I find, if I had an integer here and I keep solving, is always going to be the x coordinate or the x value associated with the filled in circle. So what I have found is that in this step length, where this function is equal to 17, this value is negative 8. And I know that the step opens to the left, and I know that each step has a length of 2, so I know that this other endpoint would have to be negative 6. And every value in between would give me a y value of 17 as well. So I'd say that my answer is that this works for any x, which is an element of this interval from negative 6 excluded, it's an open circle, to negative 8 included. And if you want to pause the video and plug in either negative 7, negative 8, negative 7.1 into this original, see if you get 17. And I think that you will. And I'll show you one other example as well. It's going to look very similar. I've kept the rule the same. I just changed this number here just to show you that I rewrote this. That's still a step that opens this way and has a length of 2. But when I isolate these brackets now, I'll bring the negative 1 to the other side, divide by 3. This is not an integer. And there is no possible way that you could solve this to make this equal to 17 over 3. Why is that? Well, it's because even if you got 17 over 3 in this bracket, the meaning of these greatest integer brackets would tell you to round that down. And 17 over 3 would get rounded down to 5. So there's no way to have any number in this bracket that gets rounded down that would equal something that's not an integer. And that just means that there is no solution in this case. And that is how you solve a greatest integer equation.